So, hello. So before OSI model, two different vendor devices was not able to communicate with each other. Now, is it possible that everyone in the world is going to purchase devices from a single company? Then guys, definitely OSI model is not required, right? Then we can connect the entire world without OSI model as well. But is it possible? We are purchasing devices according to our requirement, according to our budget, right? Few people are comfortable with HP, people are comfortable with Dell, few are comfortable with Apple, right? In the same way, like mobiles, there are lots of companies who is manufacturing mobiles, tablet, laptop, server. Getting my point? All networking devices, routers, switches, firewall, access point, IPS, IDS. There are many companies in the market who is manufacturing these devices. Okay, so to make communication possible between all vendor devices, we come up with what? OSI model. Now, is it clear, guys? Why is clear to everyone or not? Why is clear to everyone or not? See, like OSI model, like networking, whenever we are going to learn any protocols, like routing protocols, switching protocols, or any features, right, on the devices, first of all, you have to understand why. If your why is not clear, then guys, I cannot make you understand what it is and how it's work. So before talking about what and how, you have to understand why to each and every protocols in the networking. So why is clear? In simple word, what you can say, why we come up with OSI model? The reason is to make communication possible between two different vendor devices. Now, OSI model is nothing but you can say one blueprint. It is a blueprint, right? Let's say you are going to design a network for a company, or let's say you are going to design a building. You will contact with civil engineer, right? They is going to give you what? One blueprint, like how many floors will be there, right? What will be the design of room, where will be washroom, kitchen, XYZ, right? So first of all, they are going to design what, guys? Blueprint. Yes or no? After that, according to that blueprint, he is going to implement the project. Correct? In the same way, OSI model is nothing but a blueprint. It is a, you can say, common process. That let's say there is one organization, which organization is going to make communication possible between all vendor devices. So what he need to do? First, he need to design a common process for the communication, right? First, they have to design a process for manufacturing a device, hardware and software. So in the blueprint, let's say we have arranged everything, like how we are going to design a hardware, how we are going to design a software, what protocol we are going to implement in the devices, right? What will be the by default behaviors, everything like protocols, features. So we have put it, all the features, all the protocols in a common blueprint. And now I am going to distribute this blueprint to all the company who is manufacturing networking devices, to Dell also, to HP also, to Apple also, to IBM also, to all vendor devices, right? And I will tell to all vendor devices, brother, if you want to connect your hardware to network, right? How customer will purchase your device? If your device will be applicable to connect with the internet, then only you will purchase. Suppose there is one mobile in the market at very low cost, but there is one problem. Problem is you cannot connect that mobile to internet, to network. Will you purchase? No. In the same way, we tell to all vendor devices that if you want to connect your device to network, you have to design your hardware and software according to this blueprint. According to this blueprint. Now, just assume now if Dell is going to manufacture their new laptop, what process Dell is going to use? This process? Am I right? In the same way, if HP is going to design now their new computer, HP is also going to use which process? This process, common process. Now, the process of HP device and Dell device are same or not, guys? Right? So what you can say, what is OSI model? OSI model is a process, or you can say a blueprint, which define a common process of communication, right? And we have distributed this blueprint to all vendor device, all vendor company who is manufacturing networking devices, and told them to design their hardware and software in such a way, in such a way so that it can communicate with internet, so that it can connect their device to network, and they have to follow this blueprint. Now, this is what? This is one kind of task. If you are constructing a computer or if you are designing a software, guys, what you are doing? You are doing some task, correct? So if this task is complicated, how I can make it easy? By dividing. Why we divide anything? To make it easy. Let's say there is one book of 1000 pages are there, and if there is no page number, no chapter, no topics, can you read this book, brother? Right? It will be very complicated if there is no chapter, there is no topic, there is no units. Very complicated. So to make it easy so that anyone can read it, we divide this book into several parts, right? Topic wise topic, chapter by chapter. In the same way, we divide this task also in some parts to just make it easy. Okay. And you know, the basic process of communication is what, guys? Let's say I have two computer A and computer B. Basic process of communication means what? How data is going to out from this computer and how data is going to enter in this computer. Means if a computer need to send data to any other computer, how it is going to out the data on the link. What computer will do before transmitting the data on the link, and when a device will receive the data on the link, how computer is going to process the data. This is the basic process of communication between two devices, right? And this is nothing but OSI model. How data will out from your computer and how data will enter in your computer. That's it. So if someone will ask you why we come up with OSI model, so we come up with OSI model to make communication possible between different vendor devices. And what is OSI model? OSI model is a process which tells us how data will out from the computer and how data will enter in a computer. That's it. Is it clear? One second. Any question? We come up with OSI model to make, yeah. OSI stand for what? Open system interconnection. So there is theory here, you can read right in the note. Like OSI stand for Open System Interconnection Model, developed by ISO, International Standard Organization. This is the organization who have developed the OSI model and who have redistributed the blueprint to all the vendor companies to follow this process to design their hardware and software. And they developed OSI model in 1980s, but you don't need to do anything with this number. After OSI model, now different vendor devices are able to communicate with each other. It acts as a blueprint. So hope this point is also clear to you. Why we are saying it acts as a blueprint, right? So guys, as this is my task, like how data is going to out from a computer and how data is going to enter in my computer. right? So to make this to make you understand this complete process, like how data is going to out from computer, how data is going to enter in your computer, we divide this task into 7 part. We divide this task into 7 part. Okay, so we call it generally what? Layers. What do we call it? Layers. OSI layers. First layer is application or physical.
Physical.
Again, it's depend. We are talking about the perspective of sender device or receiver device. Getting my point? On the sender device, first layer will be what? Application layer. Application layer. Let's say from my computer, if I am typing www.google.com in the browser, www.google.com, right? So on my machine, OSI model is working from application layer to physical layer because my machine is the sender machine, right? So at my machine, application layer is going to generate a data for Google server. Okay. So here we have application layer. Now we are talking about the sender perspective. Done. Then second layer is, guys, presentation layer. Third layer is session layer. Fourth layer is transport layer. Fifth one is network layer. Sixth one is data link layer, and then physical layer. Fine. So we divide OSI model into 7 parts. Okay, these are upper layer. What we call to this layer? Upper layer. And as a network engineer, you are not going to work on these 3 layers, right? Actually, software developer or software engineers are working on these 3 layer, on upper 3 layers. As a network engineer, you are going to work on these 3 layer, on these 4 layers: transport layer, network layer, data link layer, and physical layer. But guys, as you are going to troubleshoot the network, sometimes you are going to troubleshoot the services like application layer services. So you have to learn these 3 layers, upper 3 layers also, right? But what I am saying, you don't need to master these 3 layers. Just you need to have some basic information about these layers. Like at application layer, there are some important protocols for network engineers that you have to learn, right? But you have to master these 4 layers: transport, network, data, and physical. Again, physical layer is easy because this is nothing but the cable, right? So as a network engineer, if you are working as a network technician, then you will work at physical layer on the cabling, right? At a As a network engineer, as a technical network engineer, you are going to work on these 3 layers: transport, network, and data layer. Fine. So now let's begin from the application layer. What is application layer? Anyone? Guys, application layer is going to provide you what? User interface. See, if I want to access Google server, what I need an interface. Like I can type www.google.com in the browser, correct? So this browser is what? This browser is an interface which is connecting me, means the actual user, to the Google server, right? So this is nothing but the application layer. Like WhatsApp, if I want to send some message to my friend through WhatsApp, right? First of all, I need an interface through that I can interact with WhatsApp server. And WhatsApp application is nothing but that application, that interface. Getting my point? Yes or no? So these are application layer. Application layer is nothing but, you can say, it is responsible to provide user interface. You can say user interface. User interface means through which you can interact with actual software. Through OSI model, sorry, without application layer, can you interact with application? Answer is no. To interact with any application, you need a what? Interface. If you want to send file to your friend, you need interface. If you want to access Facebook, you need an interface. If you want to open Instagram, you need an interface, right? Here also you can read application layer act as an interface between user and the actual application. This layer tell us that an application is internet based or not. Like, if I want to access Google server, I will type www.google.com in the browser, right? And guys, this service is internet based or not? Yes, internet is required to access Google server, correct? But let's suppose I have two computers, and from computer A to computer B, I want to send a book. Both computers are directly connected with each other. From here, I want to send one book, let's say CCNA book. Is internet required? No. Without internet also you can send, no brother. Here internet is not required. Let's say you are connected your mobile phone with this laptop, with this computer, and you want to send some photo from here to here, right? Is internet required? Correct. So who is going to tell to machine that when internet is required, when internet is not required? Only application layer. The application is going to tell to machine whether internet is required or not. Getting my point? So application layer play a very important role in OSI model. Okay, there are various services like web service, file service, remote access service, time service, mail service, etc. are used at this layer. Like if you want to access what? Web page of Google server, you need an interface, right? A Google Chrome can be interface, UC browser can be interface, Mozilla Fire can be interface. Yes or no? Through these interfaces, through these applications, you can access Google server. Am I right? Again, to access the Google server, apart from the internet, we need a protocol as well, guys. Because see, in the browser, just I am typing what? www.google.com. Once I will hit enter, there should be someone who is going to carry the traffic, who is going to generate the traffic for google.com, for the Google server. So who is going to generate the traffic for google.com? Right? So whatever tasks are there in networking, we have two options to perform that task. One, manually you can perform, or you can run a protocol. So to access all web page, like Facebook web page, Google web page, any web page, we have, guys, two protocols. We have two protocols. One is HTTP. First one is HTTP, and second one is HTTPS. So these two protocols work at which layer? Application layer, right? So see, guys, in the browser, if I am typing www.google.com and if I am hitting enter over here, are you able to see the protocol here? Which protocol my machine is using? HTTPS, not HTTP. Are you using HTTPS? Because HTTPS, Is my voice okay for all? Or is my voice is good? Okay, okay. Yeah, so I'm saying what protocol my machine is using to access the Google web page? HTTPS. But I have two options to access. I have two protocol to access web page. First one is HTTP, another one is HTTPS. The difference between HTTP and HTTPS is what? HTTP is not secure, HTTPS is secure. S stands for secure. HTTP stands for Hypertext Transfer Protocol. Okay, so now we are talking about the application layer, and at application layer we have these two protocols first, and these two protocols are responsible for web page. If you want to access a web page, you have to use either HTTP or HTTPS. HTTP stands for Hypertext Transfer Protocol. HTTPS stands for Hypertext Transfer Protocol Secure. The difference is only what? HTTP is not secure, HTTPS is secure, but both are used to access web page. In the same way, let's say you want to access file from a file server. Let's say I have network like this, switch, then I have some computers, and I have one server here. Let's say one server, this is file server, let's suppose. Switch. What is switch, guys? Server, right? Let's say this is FTP server, file transfer, sorry, file server we can say now. File server, there are some book, let's say CCNA book and CCNP book, and this PC1 want to download, let's say CCNA book. PC1 want to download CCNA book from the server. Server IP address is 10.1.1.10. PC1 IP address is 10.1.1.1. Server MAC address is, let's say 0B, and PC1 MAC address is, let's say 0A, right? If PC1 want to download CCNA book from this server, PC1 needs source MAC, source IP, destination MAC, and destination IP. Let's suppose PC1 have this all information, right? Now again, if PC1 want to download the CCNA book from the server, this PC need a protocol. This PC need a protocol to download the file, right? Like if there is one server, right, Google server, www.google.com. To access the Google web page, you need a protocol. Which protocol? HTTP or HTTPS. In the same way, to download this file from the file server, you need a protocol. And for the file access, we have again, guys, two protocol. First one is FTP and other one is TFTP. What I will do, I will discuss all application layer protocol later after the OSI model, right? So just try to understand, application layer is responsible to provide user interface between user and actual application. We have several services or protocols at application layer to access those services, to access the application layer services, right? Like, this is your company, you are network engineer in this company, right? This is your PC, let's say admin, getting my point. And your company have multiple branches in India. Let's say there is one branch in Delhi, and in Delhi branch, guys, there are few routers, few switches, right? And you are monitoring these devices from your centralized location. Let's say this location, this center is in Mumbai, right? So if you need to modify the some configuration on devices which is located in Delhi location, do you think you have to go Delhi and then you have to access the device, then you have to configure it or modify it? No. You can access all networking devices remotely as well, right? So again, this is what, guys, application layer service. Application layer is going to provide you a service. Which service? Remote access service, that you can access networking devices remotely. But again, to access a device remotely, you need what? Protocol. And that protocol can be telnet and SSH. So these all protocols work at application layer. Don't worry, we will discuss telnet and SSH protocol. All application layer protocols, telnet or SSH. For remote access, for file access, we have what? FTP or TFTP. Like this, we have lots of SSH. We have lots of protocol at application layer, and through these protocols we can access the services. Now let's move to presentation layer. What is the use of presentation layer in OSI model? So guys, it's clear with their name. See, presentation means, am I audible?
Yes, yes.
Yeah, presentation means what? Presenting something, correct? So presentation layer is responsible for encryption, decryption, compression and decompression, right? First of all, let me make you understand the meaning of encryption and decryption. So let's say I have two computer 1, computer 2. Both devices are connected through internet, right? One is in different location, another one is in different location, right? Let's say one is in India, one is in US, and both are able to communicate with each other. So guys, in first class, what I told you, if you will send your data in plain text, then anyone can read your data on the internet. Yes or no? Internet is not trusted network. This is public network. Lots of bad people are there on internet, correct? So let's say you are going to send some data, hello. Your data is, let's say, hello, right? And you want that no one should read your data, then your PC should do what? Your PC should encrypt this data. Your PC should encrypt this data. This PC should change the plain text into ciphertext. It should convert plain text data into ciphertext. Plain text means like hello, ABC, and ciphertext means converting it into a code, hard code, right? So let's say here, as I told you, I can use one algorithm, and that algorithm can encrypt H into 1, E into 2, L into 3, and O into 4. So encrypted data will be what? 1, 1, 1, 2, 3, 3, 4. This is what encrypted data, correct? So guys, which layer is responsible to perform encryption? Presentation layer, right? At the same time, at machine 2, PC2, presentation layer is responsible to decrypt the data. Because if PC2 is going to deliver this data to user, right? Again, user cannot read it. User cannot read this data, right? So again, now presentation layer is responsible to decrypt the data into ciphertext to plain text, right? So at both machine, presentation layer is working, right? At the center machine, presentation layer is doing what? Encryption. At the receiver machine, presentation layer is doing what? Decryption. Clear? Yes. Yes, Denial.
Hi, Kafur. So with there was a screen you had previously. I don't want to take us back. I was like, you drew three computers and then a switch and an access a server. So it doesn't go through the internet. Is that what you're saying? I know you were just describing something. I thought I understood it. I was like, you don't go through the internet, but then you go from the PC to switch and then to a server.
No, don't worry. Let's assume that between PC1 and server there are devices like switch, then routers, then firewall, right? We will discuss those devices also.
I'm sorry. I mean, when you were discussing the application layer, if you can move your mouse cursor to the second one where you have the SU, the PC1, and then where you point out to the server, file server, SSC, and HTTP. Just like PC1 goes to the switch, and then the switch goes to the server to
Router
download the book. So like,
here.
do you go from yeah. So like, do you go from PC1 to switch to like internet, and then the draw the diagram from the internet.
Now here internet is not required, no brother, to access the server from PC1.
Yeah, sorry, I don't get it.
Here internet is not required. Server and PC1 both are in same network.
Oh, okay.
Getting my point? So what I told
Yeah,
you in
yeah,
last class, that whenever a two device want to communicate in same network, they will communicate via switch. If two device want to communicate and both are in different network, they are going to communicate via router.
yeah.
And
I
if
understand that now.
two devices want to communicate with each other and both are connected through ISP, then they will go via firewall. This was the statement in last class. Okay,
Yeah,
don't worry, in upcoming day you will understand the complete configuration, complete design. We are going to configure this type of scenario lots of time, right? So just try to understand what is the function of application layer, presentation layer, these layer in OSI model, right? Because anyone or interviewer can ask you, brother, can you tell me what if there is no application layer in the OSI model? Then what will happen? You tell me. If there is no application layer, that means we don't have user interface. We cannot access the resources. We cannot access the services. To access any services, we need an interface, right? And again, to access the services, we need a protocol as well, because we are doing everything dynamically. We are just giving instruction to computer. Apart from it, my computer is generating data by itself. So my device need a protocol, right? So to access web page, we have these two protocols. To access networking devices together, we have telnet SSH. To access file, we have these two protocols, FTP and TFTP. Like this, we will discuss many more application layer protocols. Don't worry. And presentation layer. Next layer is presentation layer. Presentation layer is responsible to encrypt the data and decrypt the data. Sender machine will always perform encryption, and receiver machine will always perform what? Decryption. Getting my point? Like you can do same thing in your home also. Let's say you are living with your parents. You are living with your parents, like mother, father, and you are talking to your girlfriend, GF. And let's say you need to say I love you to your girlfriend, right? If you will say I love you, your mother, father all will listen you, right? And maybe they will scold you. So you want to use some other language that your mother, father don't know, right? What you can do, you can encrypt I love you into ciphertext into, let's say, 1 2 3, and you can tell to your GF, your girlfriend, that his listen, whenever I will tell you 1 2 3, just decrypt it into what? I love you. Getting my point? Yes or no? So this is what? Encryption and decryption. Same thing device is also doing. While sending the data, a sender device is encrypting the data so that no other device can read it. Only receiver device can read it. Then guys, next layer is what? And see, second work of presentation layer is what? Compression and decompression. Let's say you have one file of 2 GB, 2 GB, and you want to send this file to your friend. Let's say you are going to send it through Gmail or through WhatsApp. But let's suppose WhatsApp is not allowing you to send 2 GB data. Let's say there is one limit in WhatsApp that you can send up to 50 MB data only, or up to 500 MB data only. Then can you tell me, you do you have any option to send 2 GB data to your friend through WhatsApp? Yes. Yes. We can convert it into zip file. We can convert it into zip file. So if you are converting this file into zip file, what you are doing, you are compressing the data, right? we are reducing the size. But again, when receiver machine will receive the compressed data, they have to first decompress. Getting my point? Let's say this is my file. I want to compress it. See, compress to zip file. So what I can do through it, I can reduce the size of my file, and then I will send to my friend, and my friend will do what? My friend will extract it, decompress it. So again guys, for compression and decompression, which layer is responsible? Presentation layer only, right? So till now we discussed two functions of presentation layer. One is encryption, decryption, and compression, decompression. Then we have next layer, that is what? Session layer. Now what is the use of session layer? So let's say you are typing www.google.com in the browser, and guys, sometime when you are accessing some website, you might will get, a request timeout error, or website is not available, URL is uh, let's say request timeout, because session layer is related to request timeout only. So you are getting this type of error or not? First of all, tell me. Yes, everyone is getting sometime request timeout error, right? What is the meaning of request timeout? Meaning of request timeout is this: that whenever we are sending a request to any server, let's say to Google server, I have an interval, guys. I am expecting reply within that interval time. Let's say 2 seconds. 2 seconds is timeout, right? Means I will wait for the reply for 2 seconds only, for next 2 seconds only. It is not like that if I have sent a request to Google server, and I will wait for entire day or for entire years for the reply. No, there is short span of time. For that I will wait for the reply message, and that is timeout of that particular server. Getting my point? What I am saying, whenever my machine is sending a request to any server, it is going to maintain a timer, right? It is going to start a timer for that request. For a particular interval of time, it will wait for reply. If within that interval of time, if it will not receive the reply, it will give you what error? Request timeout error. That means we didn't get the reply message within the timeout duration, right? So who is going to maintain the time? Who is going to create the session? Session layer. Session layer. Session layer is responsible to create a session. Whenever your machine is sending a request, session layer will maintain one session, that I have sent one request to Google server. I will wait for next, let's say, 2 seconds. If within 2 seconds, if I will get reply, that is fine. Definitely we are going to provide the services to user. If we will not get the reply within this interval of time, we are going to give request timeout error. Is it clear? Okay. So see here in the note also, you can read, like application layer. There are various services like web service, file service, remote access, time service, right? We will discuss the time service also. Mail service. If you are sending mail to your friend, right? You are using application layer protocol, right? So mail is what? One kind of service. To access this service, you have to use a protocol, right? Etc. are used at this layer, at application layer. So these are the services at application layer. Now to access these services, we need a protocol, and you can see we have protocol for each services. These services can or are accessed with the help of some protocols like HTTP, HTTPS, TFTP, Telnet, SSH, SNTP, FTP, DNS, etc. And who is going to design these guys protocols? App developers design these protocols. Then presentation layer. So at this layer, data is presented in the standard format. right? Data can be encrypted, decrypted, compression and decompression at this layer. Like your 1 to 3 can be encrypted into ABC, and again ABC can be decrypted into 1 to 3. Is it clear? Then session layer. So this layer creates, maintain and terminate a session. This is done with the help of session ID. It keep data different session separately. Other use of session layer is what? Like guys, on my browser, right, there are multiple tab. You can see here I'm running WhatsApp, here I'm running Google Meet, here I can open google.com, here I can open Instagram, here I can open Facebook. See see what I want to make you understand over here. See, in this tab I am running WhatsApp. That means through this tab my device have sent one request to WhatsApp server, correct? Is it possible that I will get reply of what from the WhatsApp server in this tab? Have you ever seen this type of problem? No, right? If I am sending a request to Google server from this tab, that means I will get the reply from the Google server in this tab only, right? I will get reply from the Instagram server in this tab only. I will get reply from the FB server, Facebook server in this tab only. You know why? Because of session layer. Because session layer is responsible to keep the session different, different, differentiate. You can say, right? Session layer is responsible to differentiate the session, right? So session layer have already knowledge that from this tab number, let's say tab number 3, I have sent one request to what? Google server. So when I will receive the reply from the Google server, I will put that into tab number 3. I have sent one request to Google Meet from tab number 2. So when I will get reply from the Google Meet, I will put that reply message to tab number 2. I will put that WhatsApp reply message to tab number 1. Getting my point? So session layer is responsible to separate these session as well. So what is the responsibility of session layer? To create the session, to maintain the session, and to differentiate the session. Clear? Is it clear to everyone?
Yes.
Yes. Very good. Now, as a network engineer, your actual layer is this one, transport layer. That, as I told you, on these upper 3 layers, app developers are going to work. App developer or app tester, software developer. Those guys are responsible to work on these layers. As a network engineer, you are going to work on these layers, right? So first layer is what? Transport layer. Guys, transport layer in the OSI model is responsible for reliable and unreliable communication. So communication is going to be happen reliable or unreliable. Who will decide it? Only transport layer. Communication is going to be connection oriented or connectionless. Who is going to decide it? Transport layer, right? And through transport layer, we can identify the services. Like, in a single service, in a single server, on a single server, we can run multiple services, right? Here we can run web service as well, web service. We can run DHCP service as well here. We can run DNS service as well over here, right? So when this server will receive a request, when this server will receive a request, how this server is going to identify that this request is for web service, for DHCP service, or for DNS service, right? So this server is going to identify the service with the help of transport layer. Clear? Now, first thing that transport layer is going to provide is what, guys? Communication is going to be connection oriented or connectionless. Connection oriented and connectionless. Let me give you one example of it first. Let's say, brother, just assume that I need a glass of water. I need a glass of water, and my brother is sitting in next room. My brother is sitting in next room. So if I will say, hey brother, please give me a glass of water. Now this is, you know what, this is connectionless communication, because there is no any connection between me and my brother. Just I have delivered my data directly. I don't know my brother have received my data or not. Is he coming with glass of water or not? Yes or no? Right? This is the second way to tell to my brother to give me a glass of water. First I can say, hey brother, are you listening me? If he is not speaking it, then again I will repeat, hey brother, are you listening me? If he will say, yes brother, tell me, and then I am going to tell, brother, please give me a glass of water. Right? This time, guys, I am 100% sure that my brother have received my data, and my brother is coming with a glass of water. Yes or no? So in the second scenario, what we did, before sending my actual data, I built a logical connection with my brother. Correct? I built a logical connection with my brother. That logical connection was what? First I have sent hi, then my brother have sent what? Hi. And after that I have sent the actual data. In the same way in network, right, whenever two devices are going to communicate with each other, they have two options. They have two options. Either they can communicate without a logical connection, or they can communicate with the logical connection. Getting my point? Right? And transport layer is responsible for this, that communication is going to be connection oriented or connectionless. This is the first thing. The second thing is what? Reliable and unreliable. Transport layer is going to define communication is reliable and or unreliable. Yes, if anyone is question, please ask. Audio not clear? Yes, is it for everyone?
For me, it's clear.
For you it's clear? Yeah, voice is clear, sir. Check your internet connection. Okay. The second thing that transport layer is going to provide you is what? Reliable and unreliable. So what is the meaning of reliable? Acknowledgement. Reliable means getting acknowledgement after sending every data, each data. And unreliable means not getting any acknowledgement of data transmission. Getting my point? Okay. So guys, see, tell me one scenario where we need unreliable communication and one scenario where you need reliable communication. The real time scenario. See, if we are expecting one acknowledgement after each data, then my communication is going to be what? Slow. Yes or no?
Hmm.
If we are not expecting any acknowledgement and there is no role of acknowledgement, then definitely my communication will be what? Fast. Yes or no? So whenever we need fast communication, we are going to use unreliable communication. Whenever we need a reliable acknowledgement, then we are going to what? Use reliable communication. So right now we are connected through Google Meet, you know. So this is live streaming, guys. Here we need fast communication, right? Reliability is not important here. Let's say you have weak internet connection and you have lost some information. Let's say some people are saying that you are not audible or your voice is not clear. The reason is what? Reason is what? Reason is this is, guys, unreliable communication. Unreliable communication. My device don't have information that what data you have received or what data you have not received. But at the same time, if this meeting is reliable, then you are not going to miss a single word. Because if you will miss a single word because of bad internet connectivity, my device is going to retransmit it, because my device will not get acknowledgement, right? And for any data that my device will not get acknowledgement, for that it will retransmit the data, right? So when you are accessing, you know, Google server, or when you are watching video on YouTube, those services are, guys, reliable, right? Let's say you are watching a video on YouTube, right? And in between your internet has gone, right? Your internet went gone, and you have, already buffered some videos like 1 minute or next 2 minutes. So without internet also you can watch 1 minute or 2 minutes, yes or no? This is why. This is because of reliability, because your device have already received this data, right, and have sent it acknowledgement to sender device, to YouTube server. So reliable communication means, like my web page, right? I want to give access of my server to user, right? Watching video on YouTube. So these type of communication are reliable. All the live streaming, like going live on YouTube, or meeting through the Google Meet, Zoom, Skype, these are what? Unreliable communication, connection oriented communication. And your device have already knowledge, guys. Transport layer have already knowledge that which services are reliable and which services are not reliable, which services are connection oriented, which services are not connection oriented. Getting my point? So see, let's say I have two computer here, computer 1, computer 2, or let's say computer and server. This is server, this is computer. I'm talking about the connection oriented first. Connection oriented. Let's say this PC is going to send some data to server. Data is, let's say, A, B, C, D, E, F. These two data, right? Guys, connectionless. Connectionless means PC is going to send both data to server, right? And it is not expecting any acknowledgement. Let's say there are congestion on the link. There are congestion on link. Because of that, server have not received ABC first data. Will PC get to know that server have not received this data? No. No, never, because there is no any acknowledgement. If this is connection oriented, right? If this is connection oriented, and then if PC need to send these two data, computer PC is not going to send this data directly to server. First, it is going to establish a logical connection, right? It is going to send one SYN message. SYN message is nothing but the synchronization message. This is similar like hi. So PC is saying hi to server, then server will give one message to PC, SYN plus ACK message. What we are saying it? SYN plus ACK, acknowledgement. SYN means again hi, and acknowledgement means I get your hi, right? This is like acknowledgement. So server is saying what? Hi. It is also saying sending their hi, and is giving acknowledgement also. After that, PC will send what? I get your hi. Now this is what? This is a logical connection between sender and receiver, right? Now server have, in the upcoming day, guys, you are going to understand that how server is going to block one port for this computer. It will block one port for this computer, right? Now server is expecting data from the computer, right, in the buffer memory, and buffer memory is empty, waiting for the computer, right? And now computer is going to send this data. On server will receive this data, it will give acknowledgement that brother, I have received your ABC data, right? After receiving the acknowledgement, PC is going to send second data, right? Again server is going to give acknowledgement that brother, I have received your DEF data, like this. So for these type of work, guys, like communication is going to be connection oriented, connection less, reliable, unreliable. These are what? These are work of transport layer. Clear? Don't worry, we are going to learn lots of things in transport layer, right? Because transport layer is very important. Then just I'm giving you one overview of transport layer right now. Then guys, network layer. And transport layer is responsible to provide source port and destination port also. Now if you are thinking that what is port number, Praful, right? So don't worry, we are going to understand the port number also. For now, what I can tell you that to identify each protocol or each services, we are using a unique number, and that unique number is known as port number. That unique number is port number. To access all services, we are using a unique number, and that unique number is known as port number. And transport layer is responsible to provide source port and destination port to the data. Then guys, network layer is responsible to provide logical address, right? Source address and destination address. So my application layer has generated one, let's say, data for Google server, right? Then application layer will hand over to presentation layer. Presentation layer will do their own task, like it will perform encryption or compression. Then it will hand over to transport layer. Transport layer is going to maintain a session, create a session. Then session layer is going to hand over it to transport layer. Transport layer will do their own task, like it is going to provide source port, destination port, right? And then transport layer is going to hand over it to network layer. After that, network layer is responsible to provide the logical address, means source address and destination address, source IP address and source destination IP address. So if someone will ask you what is transport layer in OSI model, in simple word, what you can say, transport layer is responsible to provide source port, destination port. Transport layer is going to decide my communication is going to be connection oriented or connection less. My communication is going to be reliable or unreliable, right? Will I get acknowledgement or not after delivering the data? Then if someone will ask you what is network layer in OSI model, so you can say network layer is responsible to add source IP and destination IP in the data. Because do you think because source IP and destination IP a computer can forward the data? No guys. Let's say I have two computer here, simple topology, two computer A, and let's say this is server, not two computer, one computer and one server. Let's say PC1, PC1, and this is my server. Which server? Let's say Google server. Google server. URL is, let's say, www.google.com, right? And this PC want to access the web page of Google server. So first of all, you have to tell to PC that please access web page of Google server. How you will tell to machine? You will open the browser, any browser means any interface, and in that browser you will type www.google.com. Now your machine, your PC need IP address of google.com. Your machine need IP address of google.com. So this is again guys the secondary process I will tell you in the DNS that how it is going to resolve. Okay, but for now suppose your machine have already knowledge that what is the IP address of google.com, www.google.com. IP address is, let's say, what, 10.1.1.10. Your machine have already this entry in their cache, right? IP address of this server is 10.1.1.10, and IP address of your PC is, let's say, what, 10.1.1.1, right? MAC address of your PC is, let's say, what, 0A. MAC address of server is what, 0B, right? So once you will type www.google.com in the browser, your application layer will generate one data, right? Request message. It will generate a request message, and that you can call it data. After that, it will hand over, application layer will hand over this data to presentation layer. Presentation layer will hand over it to session layer. Session layer will hand over it to transport layer. Now transport layer is going to add what, source port number and destination port number. So as I told you guys, for each protocol we are using a unique number, right? So here I am typing www.google.com in the browser. That means we are accessing web page, right? And to access web page, we have two protocol. One is HTTP and another one is HTTPS. Correct? So let's assume here we are using HTTPS. So port number for HTTPS is 443. 443. So destination port will be 443, and source port number is going to be a random port number, right? Don't worry, we are going to understand port number, guys. What will be the range of port number? Because it is 16 bits value. So range of port number can be what? 02 65535, right? So source port will be the random port number. This also we are going to learn. And then transport layer will hand over it to what? Network layer. Now network layer responsibility is what? Add source IP and destination IP. So network layer is going to add source IP. Source IP will be what? 10.1.1.1. Destination IP will be what? 10.1.1.10, right? Then network layer is going to hand over the data to data link layer, lower layer, and data link layer is responsible to add source MAC and destination MAC in the data, right? So source MAC will be what? 0A, and destination MAC will be what? 0B. And then it will hand over to physical layer. Physical layer will convert it into bits, and then it will convert bits into the electric signal, and after that it will transmit from the link. Clear? Clear, guys? Now so when server will receive these bits or electric signal at physical layer, first physical layer will convert electrical signal into bits, then bits into frame, and then data link layer is going to open this header, layer 2 header, right? See, at the sender machine also data link layer have added what? This extra information. So at receiver machine also data link layer is going to remove this header, right? So first data link layer will check the destination MAC address. So destination MAC address is 0B. It will match with their own MAC address. If it will match, then only it will accept, otherwise it will discard it. So if it will match, then data link layer is going to remove this header. It will remove this header, layer 2 header, data link layer header, and then it will hand over up rest information to network layer. In the same way, network layer is going to check what? Destination IP address. If destination IP address is matching with the IP address of the device, then only it will accept, otherwise it will discard it. So destination is matching, destination IP is matching, so network layer is going to remove this header, right? Network layer header, and then it will hand over the rest information to transport layer. Transport layer is going to check what? Destination port number. Destination port number is 443. It will came to know that 443 is the port number of HTTPS, right? And guys, at the application layer, HTTPS protocol is running on the server. So transport layer is going to hand over the data to HTTP protocol. Definitely to session layer, to presentation layer, then to application layer, right? So see how OSI model is working at sender machine. At this machine, at sender machine. This is what? This is application layer. Application layer. Then we have session presentation layer, session layer. Then we have what? Transport layer. Then we have what? Network layer. Then we have what? Data link layer. Getting my point, right? So OSI model is working from application to physical. And at the receiver machine, how OSI model is working? From lower layer to upper layer, from physical to application. First it will receive data at physical layer, then it will forward to data link layer, to layer 2, then to layer 3, then layer 4, then layer 5, 6, 7, like this. Any question? So I have given you guys one overview of each layer in OSI model. First of all, why we come up with OSI model? To make communication possible between different vendor devices. What is OSI model? OSI model is a process which tells us how data will out from a computer and how data will enter in a computer, right? We divide the complete process into 7 parts. Number one, application, presentation, session, transport, network, data link, and physical. At the sender machine, my OSI model is going to work from application, then presentation, then session, then transport, then network, then data link, and then physical. But at the receiver machine, how my OSI model is going to work? Physical, data link,
network,
network, transport, session, presentation, and application. Right? This is for sender machine. This is for receiver machine. Clear? Now, try to understand the port number. What is port number? See, it is in 16 bits value. So range can be what? 0 to 2 to the power 16. Range can be what? 0 to 2 to the power 16. Range of port number, because it is a 16 bits value, right? So guys, if you will, solve this 2 to the power 16, you will get this value 65536. In the range, we can write like this: 0 to 65535. So this is the range of my port number, right? Port number is a unique ID of the protocol in computer networking, right? So whatever protocol we have at application layer, guys, each protocol will have one port number, right? And that is called well-known port number. Okay, so you can see there are two types of port number. One is well-known and another one is unknown. Well-known port number are 0 to 1024. Well-known means what? The port number which we have already defined to protocol, getting my point? And unknown, free port numbers are what? The port number which we are not defined to any protocol, getting my point? Like guys, see, on the internet there is one Google server, right? There is one Google server, and Google server is using what protocol? https. What is the port number of https? 443, right? Now let's say here in my home there is one computer, and from this computer I am going to access this Google server, right? From your home also you are going to access the Google server. From both computer, what will be the destination port number? 443, right? Because 443 is what? Well-known port number defined to this protocol. But source can be what? Each source defined, guys? Each source fixed? No. Source can be anyone, right? If I am accessing Google server from the UC browser, maybe source will be different. If I am accessing Google server from the Chrome, source can be different. If you are accessing Google server from your machine, source can be different, but destination port will be always what? Well-known port number 443, because we both are accessing what? Google server only, right? We both are accessing HTTP protocol only, right? So source port number that machine is going to use will be what? From this range, from the free. Clear? Because source is not well known. Source can be anything. Okay. So if your computer is forwarding data to Google server, always keep in mind source port number will be random port number and destination port number will be always what? Well known port number. And guys, there are some well known port number, important well known port number for network engineer that you need to keep in mind. Like port number for HTTP is what? Port number for NTP protocol is what?
Okay.
Port number for POP3 is what? Port number for DHCP is this one. Port number for SNMP is this one. Port number for Telnet is this one. Port number for SSH is this one. Port number for FTP is this one. Port number for HTTPS is 443. Getting my point?
Just TCP UDP.
Okay, at transport layer, there are two protocol. One is TCP and another one is UDP. As I told you, the transport layer is going to decide the communication will be reliable or unreliable, right? So if your service is using UDP, that means it is unreliable. That means it is connection oriented. There is no acknowledgement in UDP. If your service is using what TCP, that means it is connection oriented, it is reliable, and there is acknowledgement. Fine. So at transport layer, there are two important protocol. We are going to learn TCP and UDP. Right? TCP is a reliable protocol, UDP is an unreliable protocol. TCP is a connection oriented protocol, UDP is a connection less protocol. There is acknowledgement in TCP, there is no acknowledgement in UDP. So you can see FTP is using what service at transport layer? TCP. Secure Cell is using both. Telnet is using TCP, SNMP is using TCP, DHCP is using UDP, POP3 is using TCP, NTP is using UDP, HTTP is using what? TCP, and HTTPS is also using what? TCP. Okay, so port number is clear. Port number is 16 bits unique ID of each protocol. Range can be 0 to 65535. There are two types of port number. One is well known and another one is unknown. Well known port are the port which we have already defined to protocol, and unknown port number are the port which are free. We have not defined to any protocol. Range of well known port number is 0 to 1024. So you can see guys, these all ports number will come under this range only. You can check port number of any protocol will come under this range only. Got it? And why we have unknown port number? So that we can use this number as a source port, right? Because if my computer is sending a data to server, my computer needs source port as well and destination port as well. We have destination port that is well defined, right? Well known. So what will be the source port? Source port is going to be random port number from this range. Fine. Now, transport layer. Transport layer provides reliable and unreliable delivery, perform error correction before transmission, right? We will discuss it. Two protocols are work on this layer, that is TCP and UDP. TCP stands for Transmission Control Protocol, UDP stands for User Datagram Protocol. TCP is a connection oriented protocol and UDP is a connection less protocol. Clear? I'm expecting like these are now clear and crystal to you guys.
Yes.
Yes?
Yes.
Okay. So there are some more difference between TCP and UDP. You can read, like you can see it is a connection oriented, and hope now connection oriented is also clear to you. Connection oriented means establish establishing a logical connection between source and destination before sending actual data. How? With the help of three-way handshake. This process, sender, receiver, send message, send plus ACK and ACK. How many messages are there? Three messages, yes. So what we call to this process, we call three-way handshake. Three-way handshake. Getting my point? Three-way handshake means sender is going to send send message, then receiver machine is going to send send plus ACK message, and then again sender machine is going to send what? ACK message. This is three-way handshake. So with the help of three-way handshake, TCP protocol is going to establish a logical connection between source and destination before sending the actual data. But UDP is going to send the data directly without establishing a connection. right? So this is meaning of connection oriented and connection less. So UDP is a connection less protocol and TCP is a connection oriented protocol. TCP, we can arrange the receiving data in sequence, but in case of UDP, we cannot arrange the data in the sequence. You know the reason? Reason is what? Reason is in TCP, guys, we have sequence number, but in UDP, we don't have any sequencing. Like okay, here I have, I think, diagram for it for sequencing. I will make you understand there. For now, let me read it. Okay, so here in TCP we can arrange the receiving data in sequence. Let's say I'm sending data, like in here data is hello, then data is how, and then data is what, r, and then data is what, u, right? So first data is what, hello, second data is what, how, third data is what, r, and then fourth data is u. Hello, how are you? Suppose on the link, because of congestion, receiver machine have received first packet, fourth packet first. So receiver machine have received this packet first, u, then it have received what, how, then it have received what, r, and then it have received what, u. So what is actual data? You, how are you? Getting my point? Sorry, not you. Here it will be what? Hello. You, how are hello, right? So in case of UDP cannot arrange it in actual sequence. Actual sequence is this one. Hello, how are you? But receiver machine have received what? First you, then how, then are, then you hello, right? So in case of TCP, we can rearrange this data, right, in the actual sequence. But in case of UDP, it is not possible. The reason is what? Because in TCP, we are going to send one sequence number with each data, sequence number 1, 2, 3, and 4. But in case of UDP, we are not going to send sequence number. Getting my point? So if you have sequence number, guys, with each data, can you arrange it in the actual format, in the actual sequence or not? Yes. But if you don't have the sequence number, then can you arrange it in the actual sequence? No. Right? And as in the UDP, we don't have sequence number. So let's suppose if one data will miss on the link, right? Sender machine cannot retransmit it. Sender machine have to retransmit entire data because there is no sequence number. Receiver machine cannot inform to sender machine that which data has missed. There is no acknowledgement, there is no sequencing. So that's why in TCP data retransmission can be done, but in case of UDP data retransmission can't be done. One second. Yeah, hello. Yes, yes. Brother, do one thing. Let me call me. Call me. Let me call you after half an hour. Okay? Yeah, I'm calling you. Sure, sure. 100. Yeah. Bye. Okay. So guys, in TCP data retransmission is possible, but in UDP retransmission is not possible. Then TCP is reliable, UDP is unreliable. Flow control can be achieved in TCP, but again flow control cannot be achieved in UDP. Flow control means similar, like like if you will miss one data, right, you cannot retransmit that data. You have to retransmit the entire data. So we don't have flow control in UDP. We will discuss this also, don't worry, right? So flow control, then windowing is used in TCP. Now if you are thinking what is windowing, so don't worry, I'm going to make you understand windowing also. Like guys, as I told you, TCP is an connection oriented protocol, means after receiving each data I have to send what, acknowledgement, yes or no? So suppose I have one computer here and there is one server, right? I'm going to send 1000 number of data to server from the PC. 1000 number of data from PC to server, right? Let's say data packet 1, data packet 2, data packet 3, data packet 4, and then data packet 5. Like this, there are 1000 data packet. Okay. So see, packet number 1, packet number 2, packet number 3, packet number 4, 5, 6, like this. Okay, so just assume that when I will send first packet to the server will give me what? Acknowledgement. So after sending this data, I will wait for acknowledgement, correct? After receiving the acknowledgement, I will send this data, then again server will give acknowledgement, yes or no? Then I will send third data, after that again server will give what? Acknowledgement. Then I will send fourth data, after that again server will give acknowledgement. So if server is sending one acknowledgement after each data, each packet, then guys communication is going to be very slow, yes or no? Very slow, because I'm expecting one acknowledgement after every data. Then definitely my communication is going to be slow, very slow. So to make it fast, right, we need what? We need a reliable communication, but we need bit fast as well. So we come up with concept of windowing. Windowing. What is windowing? Windowing is a process to negotiate buffer memory of devices. Like, with the help of windowing, both devices are going to negotiate their buffer memory, and they will, select one size of data, right? That is size of buffer memory. Like, let's say the server can store 100 bytes of data in their buffer memory, right? So window size is going to be what? 100 bytes. Means, now what will happen? After receiving 100 byte of data, server is going to send what? Acknowledgement. After receiving 100 bytes of data, server is going to give one acknowledgement. So with the help of windowing, what we achieved? We reduce the number of acknowledgement in TCP process. Okay, we will discuss more about the windowing. For now, just keeping this in mind, that we come up with windowing concept to reduce the number of acknowledgement. Done. Now, so in TCP, guys, we have windowing. In UDP, we don't need windowing. Then TCP is slow, like there is acknowledgement, then definitely this process is going to be slower than UDP, and UDP is fast. So you cannot say TCP is a good protocol and UDP is bad protocol. It depends on our requirement. If we need fast communication, we should use UDP. If we need reliable communication, we should use UDP. That's it. There is no any concern related to security as well, like TCP is secure and UDP is unsecure, because most of the people are saying this TCP is more secure than UDP. No, there is no any concern regarding security between TCP and UDP. There is no any concern regarding good and bad between TCP and UDP. Both are good protocol, right? As I told you, for the video conference, right, for the live streaming, we should use UDP, and we are using UDP. For the web access, for downloading a book from the server, right? For these type of services, we are using what? UDP. Okay, then you can read more about the connection oriented here. Like, connection oriented communication is mode of communication in computer networking where a connection will established with a remote device before sending data. That is known as three-way handshake, right? When a connection will established, then actual data will send to the remote device. And you can see the diagram of three-way handshake, right? Here we have one sender machine, we have one receiver machine, right? First sender machine is sending what?
Good.
SYN message. SYN means synchronization message. Synchronization means you can say synchronize means initiate, right? This is similar like hi. We are saying hi to server, receiver machine. Then receiver is sending SYN plus ACK. Then again sender is sending what? ACK. And now guys, whatever things we are talking, in this class, in today class, you need to learn it in book. You need to now read book. You need to read it on the Google, right? Doesn't matter where you are reading, but you have to read everything, each topic in book. If you will not read it, right, if you are only watching this video, right, this joining this live session, I'm damn sure you will not get 100% concept regarding these topics. So make sure after the class, right, you will spare at least 1 hour before next class, right, to read these all topics in book. So open your book, find this topic OSI model, and start reading it. Like start reading three-way handshake. Like what is three-way handshake? Or if you don't have much time and if you don't have time to open book, right? So what you can do, you can open it in laptop, in your mobile devices. Let's say again, if you don't have much time, to read it in laptop, then you can read it in mobile as well, right? On the Google, just you can type what is three-way handshake, right? And see guys, three-way handshake, also known as three-way handshake, is a protocol or processor for establishing a connection between server and a client in TCP/IP network. A client must initiate a conversation by using a TCP handshake to request a communication session with the server, right? There are many different languages. You can check the diagrams as well, like different diagrams are there. So click on image. Like if you will spend at least 10 minutes on one topic, you will get familiar with these topics, right, with OSI layers. In the same way, you can see there are multiple diagram. In the same way, you can search what is port number. Let's say in networking, we can say like this: a port number is a way to identify a specific process in which an internet or other network message is to be forwarded when it arrives at the server, right? Then you can check some diagram as well related to port number. So you can see well known port number, right, free port number. Then you can check some important port number and protocol, like you can see this image. Getting my point? You can open this image. So these are the protocol which are using TCP service at transport layer, and these are guys the protocols which are using UDP service at transport layer, correct? So if you will read books, you will get many more information, right, as well. So here in the live class, I will make you understand, I will make you perfect, to read the book. Because without watching the live session, right, without watching this video, you can even not read it. If you will read it, maybe it will be irritating for you and you will not get the point. But after the class, after the live session, if you will read, right, it will become very easy to understand and to correlate the things. So after this class, please start reading book. Okay, now let's move. This is three-way handshake. Now you can see sequencing. What is sequencing? In TCP, sequencing is done with the help of sequence number, so that a receiving device can arrange the segment in original or order. In original order. Now guys, what is MTU? MTU stands for maximum transfer unit. maximum transfer unit. Maximum transfer unit means what? Means a interface can send how much data at a time, right? A interface can send what maximum size of data at a time from their interface. Let's say I have one router here, and this is interface of router f0/0. So MTU of this interface is, let's say, what, 1500 bytes. So it means what, this router can forward up to 1500 bytes of data from this interface at a time. Getting my point? This is maximum transfer unit. I'm not saying that it cannot receive 2000 byte of data on this interface. Yes, it can receive, but it cannot transfer. MTU is just about the transfer, that how much data it can transfer from an interface at a time, from a port at a time. Got it? And by default, MTU on Cisco devices will be what, 1500 bytes. So if this router is receiving a data whose size is what, let's say 2000 bytes. So can this router forward this data, guys, from F0/0?
Yes.
No, size of data is 2000 bytes and MTU of this interface is 1500 bytes. It can no transfer, na? It can no transfer. So like, the concern of MTU over here is this. Let's say I have a network. In my network, there is one switch, then there is one router R1, then there is one another router, let's say R2, then again we have one switch, and here I have one PC. Here also I have one PC. IP address of this PC is 10.1.1.1. IP address of this PC is 20.1.1.1. Let's say MTU of this interface is 100. MTU of this interface is 150. MTU of this interface is, let's say, what, 50 only, 50 byte. MTU of this interface is again, let's say, 40 byte. MTU of this interface is, let's say, 100 byte, and MTU of this interface is, let's say, what, 150 byte. So when PC1 or 10.1 want to communicate with 20.1, you know, PC should have knowledge that what should be the size of my data, what should be the size of one packet, or you can say one segment. That is called maximum segment size, MSS, maximum segment size. So whenever a PC is going to generate a data, PC should have knowledge. That means, transport layer should have knowledge that what should be the size of segment. At transport layer, we call data to segment, right? See, we have application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. At application layer, we call data to data. At physical layer, presentation layer also we call data to data only. At session layer also we call data to data only. But at transport layer, we call data to
Segment.
segment. At network layer, we call data to packet. At data link layer, we call data to frame. At physical layer, we call data to bits, right? So now after this class, when I will talk about the switch, so I will use frame, right? That whenever switch will receive frame or whenever switch will forward the frame. So you will came to know that it is talking about the layer 2, about the data link layer. If I am saying packet, means I am talking about the network layer. If I am saying segment, then I am talking about the transport layer. And if I am talking about the data, that means I am talking about the application, presentation, and session layer, right? So guys, at this machine, application layer don't have any foundation, right? It can generate any size of data, right? So let's say in the browser I am typing www.google.com. So application layer is going to generate one data. Let's say size of this data is what, guys? 500 bytes, right? Then application layer will forward it to presentation, then session, then transport. Now when transport layer will receive this data, The another function of transport layer is dividing large size of data into a smaller part of data. What I'm saying, another function of transport layer is dividing large size of data into a smaller part of
data.
data, right? So transport layer have to negotiate the minimum MTU between source and destination. Because let's say if this PC is going to send data of size 200 bytes, 200 bytes, can switch forward it to router? Can switch forward it to router, guys? No, because see the MTU of switch interface is what, 100 bytes only. So switch can forward up to 100 bytes of data from this interface only. Getting my point? So switch will drop it. So PC have to forward the data in such a way so that no any device between source and destination should drop it. Yes or no? So transport layer is going to negotiate the minimum MTU between source and destination. How? Again, while sending the SYN message, when it will send the SYN message to sender, SYN message, at that time it is going to negotiate the minimum MTU between source and destination. And guys, what is the minimum MTU between source and destination? What is the minimum MTU? 40 bytes? Minimum MTU between source and destination is what? 40 bytes. Yes or no? It means PC should forward data up to 40 bytes only, right? And guys, out of 40 bytes, transport layer is going to add their own header, extra information, and size of that header will be 20 bytes. Network layer is going to add what? IP header, extra information, because network transport layer will add source port, destination port. Network layer will add source IP, destination IP. So these layers are adding extra information with data. So definitely that extra information will take some space, right? So TCP header is going to take 20 bytes extra information. IP network layer is also going to take 20 bytes extra information, right? So minimum MTU between source and destination should be at least, not 40, let's say 50. 50 is the minimum MTU. Then can you tell me what should be the size of data, guys? When transport layer will divide this large amount of data, large size of data into a smaller part, then what should be the size of data? Size of data should be what? Only 10 bytes. Because the minimum MTU between source and destination is 50. And transport layer is going to add 20 bytes extra information, and network layer is also going to add 20 bytes extra information. Means total extra information is going to be what? 40 bytes. Yes. So size of one segment can be what? 10 bytes only, right? So transport layer will divide this 500 bytes of data into how many parts? 50 parts, right? 50 parts, segment 1, segment 2, segment 3, segment 4, like this, right? And with each segment it is going to add what? Source port number, destination port number. How? With the help of TCP header. It will add one header. In that header it will put source port, destination port. We will discuss about that header in the next class, right? And then network layer will add one header, and there it will put source IP, destination IP with each segment. After that PC will forward to switch, switch will forward to router, router will forward to router, router 1 will forward to router 2, router 2 will forward to switch, switch will forward to PC, like this, right? So hope now MTU is also clear to you. MTU is nothing but maximum transfer unit, how much data a interface can transfer at a time. Okay, so before sending data, the sender device will negotiate MTU of all devices between sender and receiver. It will choose minimum MTU for transferring the data. Clear? Clear, guys? So transport layer is responsible to dividing a large size of data into a smaller part of data also, and that a smaller part of data is known as segment. Okay, don't worry, tomorrow we are going to learn more about the segment, about the packet, about the frame. And let's say I have this data now. Hello, how are you? So sequence number of this data is what? 1. Sequence number of this data is 2, 3, 4. And if a receiver machine is receiving this data, hello, are you, how? First it have received this data, then this data, then this data, then this data, right? So how transport here is going to arrange it in actual sequence with the help of sequence number, right? So sequencing is only in TCP, not in UDP. So guys, in UDP there is chance, right, that your data can drop on the link and your device is never going to retransmit that data. So by the help of sequence number, receiver will arrange this data in original format. That's it. These are very basic. Retransmit data in TCP. So similar like this. See, this time I have four segment, four data. Hello, how are you? But receiver machine have received only these three data, right? Because of, let's say, congestion on the link. So remote device will request for missing segment only, right? Receiver device have received only these three segment. So receiver machine is going to send one request for sequence number what, guys? 4, right? And then sender machine will retransmit this data again. So this is how retransmission is going to happen in case of TCP. Now TCP is reliable. So TCP is reliable protocol because every device will receiving traffic will send acknowledgement to the sender that I have received the traffic. Right? That's why we are saying TCP is an reliable protocol. Flow control, using losing of data can be tragic. See, if you will lose any data on the link, definitely it can be tragic, right? So we need a safe solution in place is known as flow control. So the segment delivered are acknowledged back to the sender upon their reception. So whenever a receiver machine will receive a data, it will send one acknowledgement, and this is nothing but the flow control. This is nothing but the flow control. In the flow control, you can say this also, like if a receiver machine is have missed any data, so it will request for the missed data only, and then sender machine will retransmit that missed data again. So any segment not acknowledged are retransmitted, right? Yes, like if this sender machine have sent 1, 2, 3, 4, like 4 data, one with sequence number 1, 2, 3, 4, and let's say receiver machine have sent acknowledgement for 1, 2, 3. So sender machine will automatically come to know that, oh, that means receiver machine have not received what, segment number 4. So let me do one thing, let me retransmit it. Okay, but if receiver will send acknowledgement after every segment, then communication will be very slow. So that's why we come up with concept of windowing. In windowing, both the devices will negotiate their buffer memory. The device will elect the least buffer memory as window size. A sender will send data equivalent to window size, and then it will expect acknowledgement, right? So like between source and destination, let's say window size is what, 100 bytes, for example, 100 bytes, right? And this machine is sending data of size what, 10 bytes, right? So after how many segment sender machine will expect acknowledgement, guys? After 10 segment, yes or no? After sending 10 packets means 100 bytes of data, it will expect what, acknowledgement. Hope this is clear now. Clear or not? Tell me, guys.
Yes, sir.
Clear everyone? Okay. Day by day, if you are getting some words that you are not familiar and it is complicated for you, so don't worry, right? You can understand few words in the upcoming time also, but you should have a one basic understanding of each terms, like what is windowing. So with the help of windowing, we are reducing the number of acknowledgement. So earlier, before windowing, machine was expecting acknowledgement after each segment, but after the windowing, machine is expecting acknowledgement after a specific amount of data. That depends on window size. If window size is 100 bytes, that means sender machine will expect acknowledgement after transmitting 100 bytes of data. Then window size is used to reduce number of acknowledgement, and you can understand this with the help of diagram also. Like here, buffer window size is what? 700 bytes, and client machine is sending one segment of size what? 100 bytes. So after sending 7 segments, you can see receiver machine is sending what? Acknowledgement. Then four-way handshake. Guys, like three-way handshake is used to establish a logical connection between source and destination. Now if we have established a connection between source and destination, so after delivering the data we have to terminate the session as well. Yes or no? We have to terminate the connection as well, right? Let's say I need to send some data to my friend and I'm going to use TCP. So first I will establish a connection. My device will establish a connection with my friend device, and after delivering the data it have to terminate it, right? So to terminate the connection we are using what? Four-way handshake. In four-way, you can see four-way handshake is used to terminate the connection. In four-way handshake, sender machine, when sender machine will deliver the data successfully, all data, right, it will send one fin message. Fin message means finish. When receiver machine will receive the finish message, it will send acknowledgement that yes, I have received your fin message. And then receiver machine is also going to send their own fin message. Now let's take my finish message. I am also finished by my side. Then sender machine is going to give one acknowledgement, right? And after that, successfully both devices is going to terminate the session. Then what we have? Network layer. So as I told you, network layer is responsible to provide logical address. Router and layer 3 switches works at this layer. The main function of router works at this layer. What is this? The main function of the router works at this layer. I don't leave this point, right? Protocol used at this layer are IP, EAGRP, OSPF, ICMP, and many more. There are lots of protocols at network layer, guys, that you need to learn and that you need to master. Like you have to master some application layer protocols. You don't need to learn any protocol or algorithm at presentation layer and session layer. Not for you. Again, you have to master TCP and UDP because these two protocols works at transport layer, and then you have to master some protocol at network layer like IP protocol, EIGRP, OSPF, ICMP, right? And BGP is, by the way, application layer protocol, layer 7 protocol, right? But few more protocols at network layer. And then at data link layer also you need to learn, you need to master some protocols like ARP, address resolution protocol, which we discussed in last class. Okay. Then guys, we have what? Data link layer. So data link layer provides physical address. Physical address means MAC address, right? Till now we have not discussed MAC address and IP address. Don't worry, after the OSI model our topic will be addressing only. Okay. And at this layer error detection is done. Switch and bridge are works at this layer. This layer is responsible for forwarding data from one device to another device in a network, right? And this is the only layer in which header as well as trailer are added, right? So like transport layer is going to add extra information, that is called header. Network layer is going to add extra information, that is again header, right? But at data link layer you will see there will be header as well as trailer. right? So what is the meaning of header and trailer? Don't worry, we will discuss it, right? Then guys, protocols which works at this layer are ARP, HDLC and etc. ARP is very important protocol at this layer. Then we have what physical layer. At this layer, hub, repeaters, access point, transmit access point, and then there is comma, transmission media etc. are used. At this layer, data is converted into bits, and this is all about the OSI model, right? Now you can see PDU. PDU is form of data at a particular layer. So as I told you, at application layer, at layer 7, what we call to data? Data, right? That PDU means protocol data unit. It is nothing but form of data at a particular layer. What you call to data at a particular layer. So at application layer, you will call to your data as data. At presentation layer also, at session layer also. But at layer 4, transport layer, your data is called as segment. At layer 3, it is packet. At layer 2, it is frame. At layer 1, it is bits. Then guys, encapsulation and decapsulation in OSI model, right? Encapsulation means again adding extra information with data, and decapsulation means removing extra information from the data, right? Now let me make you understand the encapsulation and decapsulation over here, right? Because it is very important. Then we have what TCP IP model. Oh, we don't have time today. Okay, leave it for now. What we will do, we will discuss it tomorrow. We have only this topic in OSI model guys, then we will move to TCP IP. So tomorrow first we will discuss the encapsulation and decapsulation in the OSI model. Then there is no any difference between TCP IP model and OSI model. See, the only difference is what? In TCP IP model we have only this layer, 5 layers. So whatever task will be performed by application, presentation and session in the OSI model, same task will be performed by single layer in TCP IP model, that is application layer. In the same way, whatever task transport layer is going to perform in OSI model, same task will be performed by transport layer in TCP IP model. Whatever task network layer is going to perform in OSI model, same task is going to be performed by internet layer in TCP IP model. Then same data link layer and physical layer. Okay. So in OSI model, only we need to discuss encapsulation and decapsulation tomorrow, as this is very important. And after that, guys, we have headers, right? So tomorrow we will start headers and we will try to finish it as well. Then we will move to some application layer protocols, right? You can see now in application layer protocols, we need to understand what HTTP, HTTPS, Telnet, SSH, FTP, TFTP, NTP, DHCP, DNS, right? These protocols. So we need to perform lab on these all protocols. Okay. So tomorrow let me check first how much time it will take to to cover the headers. Then we will move to application layer protocols. Now if you have any question from the today class, guys, please ask. Okay. So this is day 3. In day 3 we covered OSI model, right? Next class is on header.